In this video, we're going to see how to take a quadratic function in this ax squared plus bx plus c form and figure out these things about it. What's the vertex? What's the y-intercept? What are the x-intercepts? What does the graph look like? So we already know how to answer the first question. The parabola opens up if the coefficient on x squared is positive, down if it's negative. How do we find these other things? Well, to find the vertex, to figure out what point the vertex is, one way you could do that would be complete the square to put it into that standard form, a times x minus h squared plus k. I showed you an example of that in the last video. So if you understood what I was doing and you think you can do that yourself, you like doing it that way, that is one way you can do this. Once you've got it in this form, you can just look and see what the h and the k are, and that will be your vertex. But there is another way that, in my experience, a lot of students like better. There's a sort of a formula that tells you where the vertex is. So here's the formula. Basically, what this is saying is that h, that is the x-coordinate of the formula, is negative b divided by 2a. And then k, the y-coordinate of the vertex, would be f of that number. Which, yeah, that makes sense, because once you have a number for x, you plug that in for x, and whatever comes out is the y that goes with it. The y is the f of x. So that's how you can find where the vertex is. To find the y-intercept, that's real easy. That's the point where x is 0. So if you just plug in 0 for x, you're going to get this number on the end, and that's going to be your y-intercept. To find the x-intercepts, and there might not be any, but if there are, the way to find them is take your function, set it equal to 0, and solve. Remember, x-intercepts are points where y is equal to 0. And on the graph, the y-coordinate is the value of f of x. So if we're looking for x-intercepts, that means we're looking for points where y is 0, which means we're looking for points where f of x is 0, and f of x is your function. You're looking for where that function, that whole thing, is equal to 0. So you would set it equal to 0 and solve, and here we only care about real number solutions. If you have imaginary solutions involving I, then they're not going to show up on the graph, and you don't have any x-intercepts. Okay, let's go back to that example we were looking at and work through it. First, the graph of this function would be a parabola that opens... You said up, right? Yeah, because it's a positive x squared. Now, what about the vertex? Now, if we use the method that I was just talking about, that little formula for what the coordinates are, the x-coordinate of the vertex is negative b divided by 2 times a. So for this function, a is 1, b is 6, and c would be 13. So if we take negative b over 2a, that's negative 6 over 2 times 1. So negative 6 over 2, negative 3. That's the x-coordinate. For the y-coordinate that goes with it, we take that number and we plug it into f of negative 3. And that gives us negative 3 squared plus 6 times negative 3 plus 13. So 9 minus 18 plus 13 adds up to 5. That's the y-coordinate. Now we know both coordinates. The vertex is at the point negative 3, 5. Okay, what about the y-intercept? I said that was the easy one. That's where x is 0. So if x is 0, y is 13. This graph is going to touch or cross the y-axis at the point 0, 13. What about X-intercepts? To find those, we would set this whole function equal to 0 and solve, which here we can't do by factoring. We could do either by completing the square or by the quadratic formula. But if we do it either one of those ways, eventually we're going to get to where we have to take the square root of a negative number. So that means there's no real number solutions to that equation, and thus no X-intercepts. And really, I could have predicted that, because we said the vertex was at -3, 5, and then it opens up from there. So -3, 5 is the lowest point on the graph. If you start there and only go up, you're never going to meet the x-axis. There are no points where that graph intercepts the x-axis. We can see that from the graph. So there's our vertex at -3, 5. There's our y-intercept at 0, 13. And the shape of the graph is a parabola. It's the same shape as if we just had x squared, except it's been shifted over so that instead of the vertex being at the origin, the vertex is at -3, 5. And I didn't really talk a lot about the axis of symmetry, but if I drew a vertical line right through the vertex, so it would be this line here where x equals -3, that would cut the graph in half. That would be the axis of symmetry for that parabola. Let's try another example. On this one, our function is -x squared minus 6x minus 8. So here, the graph would be a parabola. It would be the kind of parabola that opens. Did you catch that? There's a minus in front of the x squared, so it opens down. The vertex would be, well, let's see. If we do our -b over 2a thing, that would be -6 over 2 times -1. b is -6 and a is -1. But when we do -b, that's +6. And then 6 over -2, -3. That's the x-coordinate, and if we plug -3 in for x, careful about what order you do things in. This is minus -3 squared, minus 6 times -3, minus 8. So first we take x and square it, and then make that negative. -3 squared is 9, and then we have a minus sign in front of that. -1 times 9 is -9. And then minus a negative is the same as plus a positive. So -9 plus 18 minus 8 comes out to 1. So the vertex is the point -3, 1. The y-intercept, can you tell me what that is? Did you say -8 or 0, -8? If so, you are correct. And what about x-intercepts? The way we find those is we take our function and set it equal to 0, and then we solve that equation. And one thing I can do right away is, let's get rid of the minuses by just dividing both sides of the equation by -1. We're allowed to do that. So then we have positive x squared plus 6x plus 8 equals 0. Now that's a different function, but as equations go, it's equivalent to this. It's going to have the same solution. So we're working on solving this equation right now. And this can be factored. We can take x squared plus 6x plus 8 and factor it into x plus 2 times x plus 4. Because if you multiply that out, you get x squared plus 4x plus 2x plus 8. So then set each factor equal to 0, x plus 2 equals 0, or x plus 4 equals 0, which means x equals -2 or x equals -4. So that's our x-intercepts. One of them is at -2, 0, and the other is at -4, 0. So this is enough to give us a pretty good idea of what the graph has to look like. It's got a vertex at, oops, that should say -3, 1. It's got a y-intercept down here at -8 on the y-axis. And it's got x-intercepts at -4 and -2 on the x-axis. And notice, by the way, that the x-coordinate of the vertex, -3, is right in the middle, halfway between these two x-intercepts, which it would have to be since the parabola is nice and symmetric. So that can sometimes be a hint. Whatever you find for the vertex, it should be right in the middle, sort of halfway between where your two x-intercepts are, if you have x-intercepts. And of course, it does open downward. So this looks like if we took the graph of just x squared, flipped it upside down, and then moved the vertex over to the point -3, 1. Okay, let's work through one more example. 2x squared minus 12x plus 26. The graph of this would be a parabola that opens up. The coefficient on x squared is +2. And since it's 2 instead of 1, this is going to be a skinnier, narrower parabola than the last two we were looking at. What about the vertex? The x-coordinate of the vertex would be -b over 2 times a. So that would be -12, or +12, over 2 times 2, which is 4. So 12 over 4 is 3. Then plug 3 in for x. 2 times 3 squared minus 12 times 3 plus 26. Remember, squaring comes before multiplication. 3 squared is 9, and 2 times 9 is 18. Minus 12 times 3 would be 36. Plus 26 comes out to 8. So the vertex is at the point 3, 8. The y-intercept, 26, or 0, 26. X-intercepts, well, we could set the function equal to 0 and try solving, and it would turn out that there are no real solutions, none that don't involve square roots of negative numbers. But even without looking at that, I notice the vertex is at 3, 8, which is somewhere above the x-axis, and then we just go up from there. It opens upward from that vertex at 3, 8, so it's never going to touch the x-axis. No point looking for x-intercepts. So the graph, and notice I've got a slightly different scale here. On my vertical axis, we're going up by 3s. So that's why it doesn't look as narrow as you'd normally expect with this coefficient of 2. If I were drawing this to the same scale as the others, it would be a lot narrower. But it does have a vertex at 3, 8. It has a y-intercept at 0, 26. And it doesn't have any x-intercepts. Now we still have to talk about going the other way, that is, from a graph to an equation. If I show you the graph of a parabola, how can you come up with an equation or a formula for that parabola? We'll talk about that in the next video.